you guys, we are just going to take the notes that we just did, and instead of writing transformations of linear relationships, you're going to write transformations of, let's do quadratic, okay? And I'm not going to make you write these questions again, but you are going to have to write the answers again, okay? So, but not too hard. So we're just going to take it over to the graphs now, and we're going to look at the parent function for a quadratic, how to shift it up and down, how to shift it side to side, and then how to make it fatter, skinnier, taller, shorter, okay, which is stretching it and shrinking it. So let's go over to our graphing calculator. I still have the other stuff on here, so we're going to get rid of these. And my parent function for a quadratic is x squared. Okay. There's my quadratic, positive quadratic. Let's see if you know how to shift it. If I want to shift it up 2, what do you think I'm going to do? And I hope in your head you're saying, oh, you add 2 at the end of the equation. Let's see what happens. Let's change it. Now we have y equals x squared plus 2. Boom. So we took, I wonder if I get that color is so close. Oops. I don't know if we can change the color. We took the 1, our parent function here, okay, and literally every point is just up 2 points. We have shifted this vertically up, okay? So every point should be shifted up 2. Do you see how that works? Okay, and what if I wanted to shift it down? I think you guys are right. I'm just going to copy this so I don't have to keep rewriting it. Oops. So I guess that doesn't work. We will retype it. Y equals x squared, okay, 2, and then minus 2. And boom, I've shifted every point down, okay? So instead of being at 0, 0, it's now down 2, okay? Easy enough. Now, this is where it gets a little bit trickier, is shifting it side to side. Okay, so now we're going to shift it side to side. That's called shifting it horizontally. Up and down is shifting it vertically. Side to side is shifting it horizontally. And here's where the difference comes in, okay? Let's delete these all except for the parent function. All right, so see if you can tell me what difference you notice as I type this in. Okay, so as you can see, look over here. I'm going to draw on my graph. It was at 0, 0. And now I've moved it to the left 2. So each point on my orange line is now on my blue line, but it's left 2. It's to the left 2. So 2 things were different. I hope you noticed. Your first reaction is if you put a plus in, it's going to move it to the right-hand side. But remember, when you're moving horizontally, it's the opposite of what you think it's going to be. So if I put x plus 2 over here, I'm going to underline, if I put x plus 2, I'm actually moving it to the left, right? And if we remember from doing our parabolas, we should have been doing that with our parabolas. Okay, the second difference here from moving it vertically, right, is that I put the x plus 2 together and then squared everything in the parenthesis, right? Look up above. To move it vertically, I left just the x squared, and then I added the number on the outside, okay? So that's the difference between them, okay? So I'm going to do one more, and this time I'm going to move it twice. Actually, I do a couple more. This time I'm going to move it twice. I'm going to move it up and I'm going to move it to the right, okay? So I'm going to move it to the right first, actually, so y equals parenthesis, and to move it to the right, it's going to be minus, right? It's the opposite of what I think it's going to be. Let's move it 5 to the right, so it's going to be x minus 5. Look, I've already done that. Then I have to square that on the outside of the parenthesis. Okay, so you can see that black line over there. I've moved my whole parabola to the right 5. And now I want to move it up 3. I want to move it up 3. So if I just add a plus 3, look at that. Look at the graph over here. It took my orange parabola. I moved it to the right 5. That's that minus 5 on the inside. And then it moved it up 3. And that's my plus 3 on the outside. Now, check this out. I'm going to turn that black graph upside down. You want to see how I do that? I go back over, and in front of the parentheses, I make it negative. Boom. Now it's a negative parabola. So I hope this is making sense from the work that we've already done with parabolas. And we're just going to take a few minutes and talk about what it looks like to stretch it and what it looks like to shrink it. All right, so if I want to go back and stretch or shrink my original parent function, let's go back to just my orange function here. Okay, so how are we stretching and shrinking the linear relationship? It's the same thing. We're going to multiply that x value by numbers greater than 1 and by numbers smaller than 1. So if I multiply it by 5, look what happened. Actually, let's just do another one so we can compare. So if I said y equals 5x squared, okay, I have stretched it vertically by 5, right? What was once here at 1 is now here at 5. So each point is going to have gone up to 5, right? So I've made it skinnier and taller. So smaller horizontally, but taller vertically. So the same thing's going to happen that happened with the linear relationship. If I make it 1/5 instead of 5, it's going to get fatter and shorter. So let's do y equals, and then in parentheses, 1 divided by 5, x, and then squared. Oops, that x squared, it went that way because it was on the denominator. Let's put it on the outside, x squared, okay? So fatter, so look over here, you guys. Remember the orange was our parent function. Now it's fatter. Here, each point got fatter. And shorter, right? This point here got shorter vertically, but fatter horizontally when the number was less than 1. Now look, we can also turn this upside down. If I go back over, let's play around with this blue one. If I go back over here and I put a negative in front, boom. Now I've turned it upside down. What if on the end I added a plus 3? Now it's negative, but it's also moved up 3. What if I want to take this point right here where the hand is and move it to the right 5? I can do that too. If I come over, I'm going to put in another parenthesis, then minus 5 parenthesis. Okay? So if you need to watch all those maneuverings, but you need to know what each part of this equation did. So let's just take a look at this blue equation. The negative flipped it over the x-axis. The 1/5 made it shorter and fatter. The minus 5 on the inside moved it to the right 5. And the plus 3 on the outside moved it up 3. So take some time now and write down the answers to those questions that we did. If your answer to the question is just an example of what that looks like, that is also fine. Please, after you do that, watch the next video, which is for the absolute value functions.